Hi, hello, welcome to i-Tutor NCERT series. Today, we are going to discuss Class 11 Geography NCERT, Fundamentals of Physical Geography, Chapter 8, Solar Radiation, Heat Balance and Temperature. Earth is surrounded by air all around. This envelope of air is atmosphere, which is composed of numerous gases. So, in the previous chapter, we discussed about the atmosphere and about the gases. These gases support life over the Earth's surface. The Earth receives almost all of its energy from the Sun. The Earth in turn radiates back to space the energy received from the Sun. As a result, the Earth neither warms up nor does it get cooled over a period of time. Thus, the amount of heat received by different parts of the Earth is not same. Okay, so the amount of heat received by different parts of the Earth, that is not same. This variation causes pressure differences in the atmosphere. Okay, so this temperature variation that causes pressure differences in the atmosphere. This lead to transfer of heat from one region to the other by winds. So this chapter explains the process of heating and cooling of the atmosphere and the resultant temperature distribution over the Earth's surface. Now, solar radiation. The Earth's surface receives most of its energy in short wavelengths. The energy received by the Earth is known as incoming solar radiation, which is short in termed as insolation. Okay, so the incoming solar radiation, that is called insolation. Okay, so the Earth receives most of its energy from the incoming solar radiation, that is called insolation. As the Earth is a geoid resembling a sphere, the sun's rays fall obliquely at the top of the atmosphere and the Earth intercepts a very small portion of the sun's energy. On an average, the Earth receives 1.94 calories per square centimeter per minute at the top of its atmosphere. The solar output received at the top of atmosphere varies slightly in a year due to the variations in the distance between the Earth and the Sun. Okay, so the output received of the total amount of the top of the atmosphere varies slightly in a year due to the variations in the distance between Earth and the Sun. Okay, so it depends on the variations of distance between Earth and Sun. During its revolution around the Sun, the Earth is farthest from the Sun, that is 152 million kilometers on 4th July. Okay, so the Earth during the revolution around the Sun, the Earth is farthest from the Sun, that is 152 million kilometers, that is on 4th July. And this position of Earth is called aphelion. Okay, so this position of the Earth is called aphelion, that is the farthest distance from Sun. And on 3rd January, the Earth is the nearest to the Sun, and this is called perihelion. Okay, so there is two types of distances. That is first one, the aphelion, that is Earth is farthest from the Sun. Okay, that is called aphelion. Aphelion means farthest. Okay, and perihelion means nearest. Okay, farthest and near. Now, therefore, the annual insolation received by the Earth on 3rd January is slightly more than the amount received on 4th July. Okay, because in 3rd January, the Earth is in the position of aphelion, that is, it is near to the Sun. So that is why the insolation is very high. Okay, insolation received by the Earth on 3rd January is slightly high or slightly more than the amount received on 4th July. However, the effect of this variation in the solar output is masked by other factors like the distribution of land and sea and the atmospheric circulations. Hence, this variation in the solar output does not have great effect on daily weather changes on the surface of Earth. Okay. Now, variability of insolation at the surface of the Earth. The amount and the intensity of insolation vary during a day, in a season and in a year. The factors that cause these variations in insolation are: first one, the rotation of the Earth on its axis; the angle of inclination of sun's rays; third one, the length of the day; fourth one, the transparency of the atmosphere; fifth one, the configuration of land in terms of its aspects. Okay, so these are the factors cause the variation of insolation. First one, the rotation of the earth on its axis, then angle of inclination of sun's rays, then the length of the day, transparency of the atmosphere, and finally the configuration of land in terms of its aspect. The last two, however, have less influence, that is the transparency of the atmosphere and the configuration of land in terms of its aspect. The fact that the Earth's axis makes an angle of 66.5 degree with the plane of its orbit around the Sun has a greater influence on the amount of insolation received at different latitudes. The second factor that determines the amount of insolation received is the angle of inclination of the rays. This depends on the latitude of a place. The higher the latitude is, the less is the angle they make with the surface of the earth, resulting in slant sun rays. The area covered by vertical rays is always less than the slant rays. If more area is covered, the energy gets distributed and the net energy received per unit area decreases. Moreover, the slant rays are required to pass through greater depth of the atmosphere, resulting in more absorption, scattering and diffusion. Okay. Now moving forward, a passage of solar radiation through the atmosphere. The atmosphere is largely transparent to short-wave solar radiation. The incoming solar radiation, that is the insolation, passes through the atmosphere before striking the Earth's surface. Within the troposphere, water vapor, ozone and other gases absorb much of the near-infrared radiation. Very small suspended particles in the troposphere scatter visible spectrum both to the space and towards the Earth's surface. This process adds color to the sky. Okay, so a small suspended particles in the troposphere and it scatters visible spectrum both in the space and towards the Earth's surface, and this process adds color to the sky. Okay, sometimes we can see red and blue colors in the sky, so that is because of this process. The red color of the rising and the setting sun and the blue color of the sky are the result of scattering of light within the atmosphere. Okay, so this is the process, that is the red color of the rising and setting sun and the blue color of the sky. These are because of the result of scattering of light within the atmosphere. Now, spatial distribution of insolation at the Earth's surface. The insolation received at the surface varies from about 320 watt per M2 in the tropics to about 70 watt in the poles. Maximum insolation is received over the subtropical desert. Okay, so the maximum insolation that's received on the subtropical deserts where the cloudiness is the least. Equator receives comparatively less insolation than the tropics. Okay, so the tropical area receives high insolation. Okay, because the Earth is in a inclined position. Okay, it's slightly. Okay, so most of the rays receive in the tropical region. Okay, so the picture is not that much proper. Okay, now generally at the same latitude the insolation is more over the continent than over the sea or over the oceans. In winter the middle and higher latitudes receive less radiation than in summer. Okay, so that is the spatial distribution of insolation. Now heating and cooling of atmosphere. There are different ways of heating and cooling of the atmosphere. The Earth, after being heated by insolation, transmits the heat to the atmospheric layers near to the Earth in a long waveform. The air in contact with the land gets heated slowly. Okay, so the air in contact with the land that gets heated slowly, and the upper layers in contact with the lower layer also heated. This process is called conduction. Okay, the upper layer that in contact with the lower layer also get heated, and this process is called conduction. So what is conduction? That is the heating of upper layers in contact with the lower layer. Conduction takes place when two bodies of unequal temperature are in contact with one another. There is a flow of energy from the warmer to the cooler body. The transfer of heat continues until both the bodies attain the same temperature or the contact is broken. Okay, so the transfer continues till the both bodies attain the same temperature or the contact is broken. Conduction is important in heating the lower layers of the atmosphere. So the conduction is important in heating the lower layers of the atmosphere. Now, the air in contact with the earth rises vertically on heating in the form of currents and further transmits the heat of the atmosphere. This process of vertical heating of the atmosphere is known as convection. Okay, so the vertical heating of the atmosphere, that is known as convection. The convective transfer of energy is confined only to the troposphere. So the convective energy is only confined to the troposphere layer, that is the first layer. The transfer of heat through horizontal movement of air, that is called advection. Okay, so the vertical heating or vertical movement of air is called convection, and the horizontal movement of air is called advection. Okay, horizontal movement of the air is relatively more important than the vertical movement. In middle latitudes, most of diurnal, that is day and night temperature variation in daily weather are caused by advection alone. In tropical regions, particularly in northern India, during summer season, a local wind called Lu is the outcome of advection process. Okay, so that is the horizontal movement of the air, that is called advection. So Lu is the outcome of the advection process. Now, terrestrial radiation. The insolation received by the earth is in short waves, forms and heats up its surface. The earth, after being heated itself, becomes a radiating body, and it radiates energy to the atmosphere in a long wave form. Okay, so the earth receives energy in a short wave, and it radiates back the energy in the form of long waves. This energy heats up the atmosphere from below. Okay, so the energy heats up the atmosphere from below. This process is known as terrestrial radiation. Okay, so what is terrestrial radiation? The energy heats up by the earth in the atmosphere from below. That is known as terrestrial radiation. The long wave radiation. Remember, this is long wave. Okay, the earth absorbs the waves in a short and release it in a long wave. The long wave radiation is absorbed by the atmospheric gases, particularly by carbon dioxide and other greenhouse gases. So this long wave radiation, these are absorbed by atmospheric gases, mainly the carbon dioxide and other greenhouse gases. Thus the atmosphere is indirectly heated by the earth radiation. Okay, so by this process the atmosphere is indirectly heated. Now, the atmosphere in turn radiates and transmits heat to the space. Finally, the amount of heat received from the sun is returned to the space, thereby maintaining constant temperature at the Earth's surface and in the atmosphere. Okay, so that is the terrestrial radiation. Now, heat budget of the planet Earth. The Earth as a whole does not accumulate or lose heat. Okay, so the Earth does not accumulate or lose heat. It maintains its temperature. This can happen only if the amount of heat received in the form of insolation equal to the amount of lost of the Earth through terrestrial radiation. So, if the incoming solar radiation, that is insolation, and the terrestrial radiation should be equal. Consider that the insolation received at the top of the atmosphere is 100%. While passing through the atmosphere, some amount of energy is reflected, scattered and absorbed. Only the remaining part reach the Earth's surface. Roughly 35 units are reflected back to space even before reaching the Earth's surface. Of these, 27 units are reflected back from the top of the clouds and 2 units from the snow and ice covered areas of the Earth. The reflected amount of radiation is called albedo of the Earth. Okay, so what is albedo? That is the reflected amount of radiation, that is called albedo of the Earth. Now, consider that the insolation received at the top of the atmosphere is 100%. Okay, so that is, we already discussed albedo of the Earth. Sorry. Now, the remaining 65 units. Okay, the remaining 65 units are absorbed, 40 units within the atmosphere and 51 units by the Earth's surface. Okay, so there is remaining 65 units. So in this already we used about the 35%. Now the 65 units. The 65 units are absorbed, that is 14 units within the atmosphere and 51 units within the Earth's surface. The Earth radiates back 51 units in the form of terrestrial radiation. Of these, 17 units are radiated to the space directly and the remaining 34 units are absorbed by the atmosphere. That is 6 units absorbed directly by the atmosphere, 9 units through convection and turbulence, and 19 units through the latent heat of condensation. 48 units are absorbed by the atmosphere, that is 14 units insolation plus 34 units from the terrestrial radiation are also radiated back to space. Thus, the total radiation returned from the Earth and the atmosphere respectively is 17 plus 48, that is 65 units, which balance the total 65 units. Okay, so we can balance with the first amount, that is 65 units absorbed. Okay, this is termed the heat budget or the heat balance of Earth. Okay, so this amount or this is called the heat budget or the heat balance of the Earth. Now, variations in the net heat budget at the Earth's surface. As explained earlier, there are variations in the amount of radiation received at the Earth's surface. Some part of the Earth has surplus radiation balance while the other parts has deficit. Okay, so some part has the surplus radiation balance, but at the same time other parts has deficit radiation balance. Latitudinal variations in the net radiation balance of the Earth, the atmosphere system. The figure shows that there is a surplus of net radiation balance between 40° north and south, and the regions near the poles have a deficit. Okay, so the regions near the poles have a deficit. The surplus heat energy from the tropics is redistributed polewards, and as a result, the tropics do not get progressively heated up due to accumulation of excess heat, or the high latitudes get permanently frozen due to excess deficit. Okay, now temperature. The interaction of insolation with the atmosphere and the Earth's surface create heat, which is measured in terms of temperature. While heat represents the molecular movement of particles comprising a substance, the temperature is the measurement in degrees of how hot or cold a thing or a place is. Okay. Now, factors controlling temperature distribution. Okay. The temperature of the air at any place is influenced by, first one, the latitude of the place, altitude of the place, distance from the sea, the air mass circulation, the presence of warm and cold ocean currents, local aspects. Okay, so these are some of the factors which control the temperature distribution. Now, first one, the latitude. The temperature of a place depends on the insolation received. It has been explained earlier that the insolation varies according to the latitude, hence the temperature also varies accordingly. Okay, we know the insolation varies according to the latitude and the temperature also varies accordingly to the latitude. Second one is the altitude. The atmosphere is indirectly heated by terrestrial radiation from below. Therefore, the places near the sea level record higher temperature than the places situated at higher elevations. In other words, the temperature generally decreases with the increasing height. The rates of decreases of temperature with height is termed as the normal lapse rate. Okay, so the rate of decrease of temperature with height, this is called normal lapse rate. It is 6.5 degrees Celsius per 1000 meter. Now, distance from the sea. Another factor that influences the temperature is the location of place with respect to sea. Compared to land, the sea gets heated slowly and loses heat slowly. Land heats up and cools down quickly. Therefore, the variation in temperature over the sea is less compared to land. Okay, so the variation in temperature over the sea is less compared to land. The places situated near the sea come under the moderating influence of sea and land breezes, which moderate the temperature. Okay, so the places which come under the sea area, that is under the moderating influence of the sea breeze and land breeze, and which can moderate the temperature also. Now, air mass and ocean currents. Like the land and sea breezes, the passage of air masses also affect the temperature. The places which come under the influence of warm air masses experiencing higher temperature. Okay, so just like the land breeze and the sea breeze, the air mass also affect the air mass and ocean currents also influence the temperature. That is, the influence of warm air mass that experience a higher temperature, and the places that come under the influence of cold air mass experiences low temperature. Similarly, the places located on the coast where the warm ocean currents flow record higher temperature than the places located on the coast where the cold currents flow. Now, distribution of temperature. The global distribution of temperature can well be understood by studying the temperature distribution in January and July. The temperature distribution is generally shown on map with the help of isotherms. The isotherms are lines joining places having equal temperature. So what is isotherms? They are lines joining places having equal temperature. In general, the effect of latitude on the temperature is well pronounced on the map as the isotherms are generally parallel to the latitude. The deviation from this general trend is more pronounced in January than in July, especially in the northern hemisphere. In the northern hemisphere, the land surface area is much larger than in the southern hemisphere. Hence, the effect of landmass and the ocean currents are well pronounced. In January, the isotherms deviated to the north over the ocean and to the south over the continent. This can be seen on the North Atlantic Ocean. Okay, so what happened in January? The isotherms deviate to the north over the oceans and to the south over the continent. Okay, in continent, the isotherms came to the southern region, but in the ocean, it's come to the north region isotherms. This can be seen in the North Atlantic Ocean. The presence of warm ocean currents, Gulf Stream and North Atlantic Drift make the Northern Atlantic Ocean warmer and the isotherms bend towards the north. Over the land temperature decreases sharply and the isotherms bend towards the south in Europe. It is much pronounced in the Siberian plain. Okay. The mean January temperature along 60 degree east longitudes is minus 20 degrees Celsius both at the 80 degree north and 50 degree north latitude. The mean monthly temperature for January is over 27 degrees Celsius in the equatorial oceans, over 24 degrees Celsius in the tropics, and 2 degrees Celsius to 2 degrees Celsius to 0 degrees Celsius in the middle latitudes, and minus 80 degrees Celsius to minus 48 degrees Celsius in the Eurasian continental interior. Now, the effect of the ocean is well pronounced in the southern hemisphere. Here, the isotherms are more or less parallel to the latitudes and the variations in temperature is more gradual than in the northern hemisphere. The isotherms of 20 degrees Celsius, 10 degrees Celsius and 0 degrees Celsius runs parallel to 35 degrees south, 45 degrees south and 60 degrees south latitudes respectively. Okay, so the 20 degrees Celsius isotherms run through 35 degrees south latitudes and 10 degrees Celsius into 45 degrees south and 0 degrees Celsius into 60 degrees south latitudes. In July, the isotherms generally run parallel to the latitude. The equatorial oceans record warmer temperature more than 27 degrees Celsius. Over the land, more than 30 degrees Celsius is noticed in the subtropical continental region of Asia along the 30 degree north latitudes. Along the 40 degree north runs the isotherm of 10 degrees Celsius and along the 40 degrees south, the temperature is 10 degrees Celsius. The highest range of temperature is more than 60 degrees Celsius over the northeastern part of the Eurasian continent. This is due to continentality. The least range of temperature, that is 3 degrees Celsius, is found between 20 degrees south and 15 degree north latitudes. Now, inversion of temperature. Normally, temperature decreases with increasing in elevation. It is normally called lapse rate. At times, the situation is reversed and the normal lapse rate is inverted. It is called inversion of temperature. Okay, so the inversion of normal lapse rate, that is called inversion of temperature. Inversion is usually of short duration but quite common nonetheless. A long winter night with clear skies and still air is ideal situation for inversion. The heat of the day is radiated off during the night and by early morning hours. The earth is cooler than the air above. Over polar areas, temperature inversion is normal throughout the year. Okay, so over the polar area, the temperature inversion is normal throughout the year. Surface inversion promotes stability in the lower layers of the atmosphere. Smoke and dust particles get collected beneath the inversion layer and spread horizontally to fill the lower strata of the atmosphere. Dense fogs in the mornings are common occurrence, especially during the winter season. This inversion commonly lasts for few hours until the sun comes up and begin to warm the earth. Okay, so this inversion is commonly lasts for a few hours. The inversion takes place in hills and mountains due to air drainage. Cold air at the hills and mountains produced during the night flows under the influence of gravity. Being heavy and dense, the cold air acts almost like water and moves down the slope to pile up deeply in the pockets and valley bottoms with warm air above. This is called air drainage. It protects plants from the frost damage. Okay, so what is discussing heavy and dense, the cold air acts almost like water and moves down the slope to pile up deeply in the pockets and valley bottoms with warm air above. And this is called air drainage, and this helps plants from the frost damages. Okay, this protect plants from the frost damage. Okay, so that's about the inversion of temperature. So it's about the chapter. If you have any doubts, you can comment below. For more videos, do like, share, subscribe.